All right, let's compare the square root of x squared, the cube root of x cubed, and the fourth root of x to the fourth. When we take an even radical, and in this first case it's a square root, we have a circumstance where a negative can't come out of an even root. So to make sure that it's always positive, then we have to put absolute values around it. In the second case, however, you do want negatives come out of odd roots. Like when we did an example where we were taking the cube root of -8. That was -2. So we do want a negative to come out of an odd root. So we definitely don't want absolute values around that. But then in this third case, again, we have an even root. We're taking the fourth root. So to make sure that a negative does not come out, then we use absolute values. So now we'll compare the fourth root of x to the fourth root of x to the eighth. In the first case, we've already seen that it's just the absolute value of x. But why in the second case is there no absolute value? Well, we know for sure that it's x squared, and because x squared is always positive, if x is a negative and I square it, I get a positive. And if x is a positive and I square it, I get a positive. So I don't have to worry about the absolute values here. Because remember, the absolute values are to make sure that a negative does not come out of an even root.